Hey everyone, Bukoola Simon Peter here, and welcome back to our channel. Before we move to importing AutoCAD models into SolidWorks, let's do a quick focused explainer on the core sheet metal concepts you need for accurate bends and flat patterns. And in this short video, we'll cover these key terms in their order. We'll be covering the K factor, the Y factor, the neutral axis, the bending allowance, and bending deduction, flat length, and then we shall do some small design tips. So let's dive in. The K factor is the ratio that locates the neutral axis after bending. Sorry, I made a mistake in the formula. The K factor, K is equal to small t over t, where t is the distance from the inside surface to the neutral axis, as you see in the diagram, and T is the thickness of the metal or the material. During bending, the neutral axis shifts inwards because the inner side compresses while the outer side stretches. The common values for the K factor they are 0.4 to 0.5 for milled steel, 0.4 to 0.45 for stainless steel, and 0.3 to 0.4 for aluminium. In SolidWorks, the default safe value is 0.42, which is a perfect starting point for most designs. The K factor varies based on material type, bending methods. For example, you have air bending and bottoming, and the radius to thickness ratio. When you go to the Y factor, what we must know that the Y factor is derived from the K factor and used by some CAD systems. So the Y factor, Y is equal to the K factor times pi over 2. SolidWorks primarily uses the K factor, so we might not see the Y factor anywhere, but understanding Y factor helps when switching softwares or while reading older documents. The neutral axis is the line inside the material where no length change occurs. Here we express no compression or tension. It either shifts inwards during bending, where it goes closer to the inside radius. This shift is where we use the K factor to calculate the accurate flat patterns. So when you go to the bending allowance, which is the arc length added to the flat pattern to account for the bending along the neutral axis. So its formula is the bending angle times pi times r times k times t divided by 180, where we have r as the inside bending radius, k the K factor, and t as the thickness of the material. Bend deduction is how much length you subtract from the overall dimensions due to the bend or the shortening effect. And the formula is BD equaling to 2 times OASSB, where we have OASB as the outside setback minus BA. Remember, BA is the bending allowance. We also have some small information about the flat length. This helps in sheet flattening and knowing what you need. So these formulas are very important. Finally, before we close our video, let us look onto the design tips. So you should make sure the minimum inside bend radius is greater than the thickness. This helps to avoid cracking. That's point number 1. Flange length must be greater than 4 times the thickness. The holes must be greater than the thickness, and the diameter must be greater than the thickness away from the bends. Add ribs, hems, and flanges for stiffness without increasing thickness. Always test the K factor with your material and process for best accuracy. So that's the essentials. Mastering this means you are your SolidWorks sheet metal parts will unfold correctly and be ready for manufacturing. If this helped you, hit like, subscribe for the series, and comment what your usual K factor for the materials you bend. The next video, we're going to be importing AutoCAD DWGs and converting 2D to 3D in SolidWorks. Don't miss it.